it says find the total differential of the function. Then I say, for part B, note that the total differential generalizes to functions of more than two variables, and it generalizes in a very consistent way with the first version of dz. In this case, it would be dw in B. Well, B is kind of a generalization, so you have to kind of extrapolate. To review, let's do the generic formula that you would use in part A first. So dz, what's the formula for dz? You take the partial, if you consider z equals f of xy, you take the partial of f with respect to x, right? And then well, when you use x naught, y naught, you're really thinking of it as specific values. Here I'm being more generic. I'm saying x and y can vary, and then we can always fill it in for any values that we have. So, so derivative of f with respect to x, dx, right? Plus derivative of f with respect to y, and then dy. So that's the formula you would use in part A. In part B, well, you wouldn't use dz anymore. You would use dw, and you would have another term. But what's the formula that makes sense? So now you would consider w a function of x, y, and z. So you could write it like that. So then see if you can generalize this formula.
F subscript z.
Well, f subscript, it'd still be the derivative of f with respect to x for the first term.
Oh, sorry, I was just building off that.
And then it would be, the inputs would be x, y, and z. Just make sure you understand that the inputs are x, y, and z. It's going to get awfully long if I write that every time. And then dx, right? Plus what?
Same thing, but with y. So f subscript y, x, y, z, dy.
Right? And then plus
F subscript z.
dz. So it generalizes in a very consistent way. And then what does that formula tell you need to do?
Take a bunch of partials.
Find the partials. The only partial that's going to present somewhat of a challenge is the one that has two variables in it, right? One with x's. Because there's an x in the exponent. Yeah, so product rule.
Okay.
Let's try it. So you're going to take f sub x. So you're focusing on this guy, right? X times z times e to the y. And product rule. So let's take the derivative of, okay, I would rewrite it like z times x times e to the xy. Z is just a constant here. And so it's x would be the first function, or z times x would be the first function if you like. And then e to the xy would be the second function. Product rule, regular product rule. So what would you get there? The derivative of the first, which would just leave you with z times e to the xy, right? Plus, so we have this function x, z, e to the xy, and we want to take the derivative with respect to x, right? There's two functions of x there, x times z, or z times x if you want to switch the order, times e to the xy. So take the derivative of the first, and that x disappears, leaves you with just the z, e to the xy. Everybody believe that? Then take the derivative of the second. This guy's the second. With respect to x still, so plus what? You have this x times this z not going away. And then you're taking the derivative of the second with respect to x. So, so what's, okay, you got this is the inner function. So what's the derivative of x times y with respect to x? Y. Okay, so x times y times z e to the xy. So then that was the only hard one. Derivative of f with respect to y then. So again, look at this guy. The only unknown is y in the exponent, right? So you're gonna, the derivative then is gonna be x e to the xy times the derivative of the inner function, which is the exponent, with respect to y. So what's left there? An extra factor of x out in front. So that would get you the x squared, wouldn't it?
Where'd the z go?
It should still be there. I think I erased it on accident. So that's the function I should have been looking at, which means there's an extra factor of z that I didn't write down. Would have been easier to erase it. Now do you agree? Now the derivative of this guy with respect to z. X, the z is going to go away, right? Make one, and then the rest of it stays the same. So that really was the easiest one. Okay, got it. Now all we have to do is fill in this guy. Would you buy that? Okay, so dw is what? Well, this ugly thing. Put it in parentheses, z e to the xy. I guess you could factor out an e to the xy if you wanted to. I don't know if I did that in the answers or not. So if I copy that down, then times just dx, right? Does that look right to you? And then plus what? The x squared z e to the xy dy. Does that make sense? And then what's the final guy? So plus this guy times dz. So x e to the xy dz. There we go. Took us a while to get there, but we got it.